You just move your table where you want that to go. I first came to Smith College in 1974. I was hired as a technician for the sciences to build and repair laboratory equipment. A lot of people from all over campus were very interested in what was going down here, and because of that, the word spread and we started getting inundated with students in the shop.
The historic purpose of this facility was to fabricate apparatus for science. Greg Young, who has been here for 39 years, evolved into sort of a teaching role, and we would bring students in and let the students actually make something.
I'm building a kalimba, which is an instrument, and these are going to be the teeth. It's like a thumb piano. It's
important for us to be able to quickly turn parts around. The reality is we have very limited time with the students, and we want to try to make the most of it. We don't have weeks to fine-tune the process. We need to make things in a few hours. And draw a line that you won't go past. Okay. You know, let it circular, and then come back and start scraping with this tool and see how it goes for you. So in 2009, the engineering department received a grant from the Branta Foundation for the sum of $1 million, and the purpose of this grant was to buy equipment. At this time, we had no computer-controlled equipment, none. And the industrial world today is pretty much owned by computer-controlled equipment. It's just how it works. We brought in milling machines and a lathe, and this water jet machining center behind me. All of these are computer-controlled machines that perform functions that we used to do traditionally. So I was trying to bring in things that changed what we could do. So this water jet machining center behind me changed the game.
Are there any other pieces? I can look and see. I'm sure there are. So you're going to check that. Yeah. Keep this. Yeah, that fits perfectly.
Probably when I was a child, if anybody had asked me if I was going to be a teacher when I grew up, I would have probably told them they were not thinking in the right direction. For me, the teaching process seemed to come fairly naturally. It's a matter of being able to make things that seem complicated, tell it in a way that it's understandable. So the hands-on course here not only teaches those skills, but those skills apply a lot to the process of learning three-dimensional thinking, which is really critical when you're doing some program like engineering, especially if it's mechanical, where you need to be able to design things in 3 dimensions.
All right. You good? Okay. Sophie. Okay, first on first, yeah?
The trick is to be able to introduce people to machines that can be very scary in a way that allows them to feel comfortable, but at the same time to feel safe, so that they won't get injured. Turn down like so. You've got a problem. You step on that, it locks up the spindle and it turns off the electricity.
You turn it 90 degrees and run it through. Remember to keep your fingers way back. Excellent. We're going to reiterate a lot of the safety stuff over and over again because it's very important that we keep you nice and safe. We send you out with as many digits and body parts as you came in with.
We are unique as a smaller liberal arts school to have a facility like this. I think some of it comes from our history. We already had something here that really helped us.
From seeing students come into a space like this and a little bit timid perhaps at first because of the nature of the machines here, But then suddenly realizing how much fun they're having is just wonderful to see. They'll come in and get done with these projects and they're just bubbling with joy as they go out the door. Look what I did, look what I did. It's really a lot of fun.